All the way back in the beginning of August, we announced that we would try to use fuses to ignite the second stage engine instead of using the ejection charge of the first stage engine, which hasn't been working. So we started making fuses with a recipe from a video that I will link in the description. For the first batch, we wanted to see which material for the fuse was the best. We tried out yarn, a crumpled napkin, and a rolled up paper towel. After testing, we found that the paper towel gave us the fastest and most explosive results, which is exactly what we want. We then tested whether we wanted a tight rolled up fuse or an unrolled fuse. The rolled up fuse burned faster and more explosively. This happened because the pressure built up inside the fuse until it exploded. While testing this batch, we also found that if we twisted up the tip of the fuse, it would cause a small explosion which would probably ignite the engine, as seen in this video. Our next batch tested how tight we wanted the fuse to be twisted up. Less twist gave us more flame but was slower, and tight twist was faster but had less flame. We ended up choosing something in between the two. We then bought a clear plastic tube and we 3D printed a ring to hold in the fuse inside the tube. We placed an engine on the top and bottom of the tube and stuck an Estes rocket on the top engine to keep the flight controlled if it started flying. The reason we used this clear plastic tube was to see what was going on inside the tube during the test. We then drove to the school where we normally do our tests, but it was filled with hundreds of people playing soccer. We were just about to cancel again after almost 2 months of canceling when we remembered that there was another school nearby. The problem was that all the gates to enter the school were locked. We were again about to give up when my brother said that he could climb over this fence and open the gate for us, so he did. Finally, we were going to test the fuse. But no. None of our 3 launch controllers were working. This meant we couldn't fire the engine's igniter. We wanted to check that everything inside the controllers were fine, but we needed a screwdriver for that, which we didn't have. So we used the head of some random nail we found lying around. Unfortunately, all the electrical connections are inside a part of the controller we aren't supposed to open, so we couldn't fix the problem. We needed some way to bypass the electrical connections in the controller. We finally decided to just connect the igniter's wires directly to a launch controller's battery, but we needed to sacrifice one of our controllers for that. A controller's wires connect directly into the controller, so we couldn't just disconnect them. We needed to cut them. We didn't have a knife, so we used a launch pad plate to cut it. Finally, we were able to test our fuse. You can't really see much from this video, but the fuse ignited and the second stage didn't. We don't know if the fuse helped or just blocked the ejection charge from igniting the second stage. We will do another test like this soon. Make sure to like and subscribe, and we'll see you later.